Welcome to Solutions Studio. This is a free series on C programming language. If you like these videos, please subscribe to follow along with this series. Also, please like and leave a comment and share the video to help spread this series. Hello and welcome to this episode. In this episode, we want to create yet another simple C program for adding two integers. Let's go and get started. First, I want to create a new source file for this program and start writing my code. Let's add our preprocessor directive, the standard input-output library. Include stdio.h. Now some indentations. Now I want to define my main function, integer main void, the body of my main function. Now I'm going to define two variables, integer 1, and I will give it an initial value of 0, semicolon at the end of this statement, defining another variable of type integer. I will call it integer 2, and I will give it an initial value of 0 and the end of the statement. Now I want to create a prompt using printf. What would this prompt say? It would say enter the first number. And semicolon at the end of this statement. Now the user will enter a number and I want to capture that number using scanf. What do I want to capture? The type of my variable and the name of my variable. I will create the same printf and scanf statements for the second number. And this second number will be stored in the second variable, integer 2. End of my statement with a semicolon. Now I want to create yet another variable. I will call it Sam. I will give it an initial value of 0. End of my statement. And Sam will have the value of integer 1 plus integer 2. End of the statement. Now I want to create yet another message on the screen using printf. The printf will say Sam is the type of the variable and a new line at the end of this message. In this message, I defined a variable. Now what would be that variable? It would be the variable Sam. End of the statement. Now let's go and save this program first. Save, not in episode 1. This is my episode 19, so I will save it in here. I will name it another simple program. It is going to be a C source file. Save. Let's go and compile and run it. My first number will be 23. Then I press enter on my keyboard. My second number will be 45. Then I press enter on my keyboard. And I'm given the sum of these two numbers. The sum is 68. Now it's okay if you didn't understand how this program works. This was just an introduction. In the coming episodes, we are going to dig deep into this program, and I will try to explain every single detail of this program for you. That's it for this episode. Stay tuned for the coming episodes. In the last episode, we wrote this code and we tried to run it, and it was running perfectly well. Now let's go and inspect the line 5th and 6th of this program. In these two lines, I have defined two variables. Variables are like space holders in memory. To store a value in memory, we need to have a variable for that value in the memory. And variables have types. They can be of different types. In this example, I have used the type integer. And integer numbers are whole numbers. That means that they can be positive numbers and also negative numbers. Let me write a comment in here. Maybe whole numbers can be like 0, 100, 5,000, or even minus 200 or minus 1900. These are all whole numbers and they can be stored inside an integer variable. And the next thing that I have done is that I have initialized these variables. I have initialized both of these variables with the value 0 using this equal operator. Initializing a variable means that we are giving an initial value to that variable. And it's always a good practice to initialize your variables because it will help to avoid many common problems. Now I will write a few comments in here so that we know why we have defined these two variables. The integer one will hold first number that the user enters, and the integer 2 will hold second number that the user enters. And these two comments will help us understand the purpose of these variables. That's it for this episode. See you in the next episode where we will go deeper into this program. Hello and welcome to this episode. In this episode, we want to emphasize that variables should be declared before they are used. That means that this declaration for integer 1 and integer 2 is very important before we use it here in the scanf function. Suppose we did not declare it first, what will happen? Now let's go and check that. Maybe I want to make this a comment so it cannot be used anymore in the program, and then I want to run this program. Now you can see that I got an error. This is an error and the program cannot be compiled because integer 1 is undeclared. As we said before, any variables that are going to be used in a program, they are supposed to be declared first. And for now, you should know that they should be declared inside the main function, not outside of the main function. And also remember to declare your variable very close to where you want to use it. So because we have used integer 1 and integer 2 in these scanf functions, we declared it right before these functions. And because we used sum here in the printf function, we declared it right before the printf. And that's why it's very important to declare your variables close to where you're going to use them. That's it for this episode. See you in the next. As we created our variables in the last episodes, you know that we have 3 variables in this program: integer 1, integer 2, and Sam. And the names for these variables are called identifiers. Identifiers can have letters, digits, and also underscore, but you cannot begin an identifier with a number. Also remember that C is case sensitive. That means that if I create another variable and I will call it integer with a capital I, it will be different from this integer 1, and it will be considered a different variable. It's also convention that the variable names should always start with a small letter. Although it's not mandatory, it's common practice and it's a good practice, and it will indicate that this identifier is a variable. Let me delete this unused variable. Also remember that creating meaningful names for the variables is important, and it will be self-explanatory. Instead of having a lot of comments, it will make the program readable and easier to understand. And here I could have the name of this variable A or B or C or whatever, but it would not make any difference, and I had to put a lot of comments to explain the variable. Instead of that, integer 1 is a very self-explanatory name. Also, don't start your variable names with a underscore. Even though underscores are allowed in the variable names, it's recommended not to start your variable names with an underscore. Identifiers can consist of multiple words. For example, integer, my, number. Or I can create another type of convention, which is my number. Both of this is correct, and we can separate identifiers using a underscore, or we can create a camel case. The first word would be small and the second word a capital letter. That's it for this episode. See you in the next. You know that in line 9 and in line 12 we used scanf, and we used scanf to obtain some information from the user. The scanf function reads from the standard input, which is usually the keyboard. The F in the scanf stands for formatted, and the scanf has 2 parts, 2 segments. The first part is called format control string, and it indicates the type of data that the user should enter. The %d specifies that the data should be an integer. The D stands for decimal integer. Scanf's second argument begins with an ampersand, and it's followed by the variable name. The ampersand is the address operator, and when it's combined with the variable name, it tells scanf the location or the address in the memory for the variable integer 1. Scanf then stores the value that the user enters into that memory location. For novices and people who have programmed in other programming languages, they do not require this notation of ampersand, and it's confusing for them. But for now, just accept this as a fact here in C programming. If we forgot the ampersand before a variable name in a scanf statement, that will typically result in an execution time error. And this will cause an access violation. In line 9, the computer waits for the user to enter a value for the integer 1. And when the user types an integer, then presses the enter key to send the number to the computer then places that number in the integer 1 variable. Any subsequent reference to integer 1 in the program will use the same value that the user entered. These two functions, printf and scanf, facilitate interaction between the user and the computer. And this interaction is called interactive computing. That's it for this episode. I hope to see you in the next episode. Let's go and talk about line 15 of this program, which is an assignment statement. This line of program calculates the total variables of integer 1 and integer 2 and then assigns the result to the variable sum using the assignment operator equal. The assignment operator is equal. If we were to read that statement, we would read it as sum gets the value of the expression integer 1 plus integer 2. And this way most of the calculations are performed in assignments. See you in the next episode. Operator equal and the operator plus or addition. These two operators are called binary operators because they have two operands on each side of them. One on this side, one on this side. And as you can see for plus, one on this side and one on this side. It's recommended to place spaces on either side of binary operators so that the program becomes readable and the binary operator stands out in the statement. Let's go and remove the spaces and you will be able to see that this statement will become less readable. You can see that having spaces makes this program more readable. That's it for this episode. See you in the next. Here in the line 17 of this program, you can see that after sum is, there is a placeholder for an integer, and this placeholder is called the format control string. The value of the sum is going to be inserted in place of %d, and the conversion specification for an integer, which is a %d, is the same for printf and also scanf. That's it for this episode. See you in the next episode. You can initialize a variable and also create its definition as we are going to do it in here. Here I will try to make this line a comment so that it's not going to be used anymore, and in here I'm going to add an integer. Now I have declared this integer, which is the sum, and I've also defined it with this value, which is the sum of integer 1 plus integer 2. So this is a more clever way of declaring a variable. Let's go and execute this program. 23, 23, 46. You can see that the program still works. And that's a good trick to remember about combining a variable definition and assignment statement. Now in this episode I want to show you something different. The very fact that we don't need the variable sum and we can do the calculations of adding integer 1 and integer 2 inside the printf statement. Let's go and do that. I will make this part a comment, and instead of the variable sum I will do the calculation of integer 1 plus integer 2, and there will be no need for this additional variable. Let's go and execute this program. 23, 23. You can see that the program is still working fine. And that's it for this episode. I hope to see you in the next episode.